Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of permutations and combinations, and today in this class we are beginning with the examples of combinations. In the previous classes we just understood the concept of combinations and a few important formulas related to the formula of NCR. Alright, so as you already know, NCR stands for n factorial divided by r factorial into n minus r factorial. Well, so let's begin with the first example here. If 10c x minus 1 is greater than 2 into 10cx, then x belongs to which of these following sets? Alright, so let's begin with the NCR formula. Alright, and then we can reduce it to get the required set to which this x belongs to. Well, so first NCR formula, so that is 10 factorial here divided by, you have got x minus 1 in place of r, so x minus 1 factorial, and then n minus r, so 10 minus x minus into minus will be plus, so I am avoiding one step here. Okay, so which is greater than twice 10 factorial divided by NCR formula here as well, so x factorial and 10 minus x factorial. Alright, so straight away cancel out this, correct, because when you bring it here it will be divided. See, this is positive, so you can divide by a positive quantity, the inequality does not change, right. Similarly, now what I can do is I can expand this x factorial as x into x minus 1 factorial, hence x minus 1 factorial also gets reduced, and this is 10 plus 1, so that's 11 minus x, correct. So I can reduce that 11 minus x in the next step. Let's write the next step. So this is x minus 1 factorial, and this is 11 minus x factorial, which is greater than, right, so that is twice x into x minus 1 factorial, and then here you have got 10 minus x factorial. Alright, so how about this? Now see, cancel this also straight away. Factorial notation, basically it is positive thing, okay, you don't have negatives because it is product of first n natural numbers. What is n factorial? Product of first n natural numbers. So whichever factor you will see, it will be always positive because you don't have negative integers there, only the natural numbers, right. So obviously that will be positive. There is no meaning for minus 1 factorial, minus 2 factorial, meaningless, right. Alright, so since it is positive we can get rid of it, okay, inequality doesn't change. And what about 11 minus x factorial? So 11 minus x factorial can be written as 11 minus x into 11 minus x minus 1, correct, because n factorial is n into n minus 1 factorial. So 11 minus x factorial is 11 minus x into 11 minus x minus 1. What is it? 10 minus x factorial. Alright, so that's greater than twice, you have got x, and this is 10 minus x factorial. Now that also gets cancelled. Okay, so finally let's work out with whatever remains here. So this is x and then you have got 11 minus x and you have got 2. So let's bring that x here. So x is greater than this 11 minus x will be multiplied here obviously. So 2 times 11 minus x. So that means x is greater than 22 minus 2x. So minus 2x becomes plus 2x here. So that means this is 3x is greater than 22. So which means x is greater than 22 by 3. Correct. So which is 7.3 and then 3. So like that 22 by 3, correct. Okay, anyway, so it's greater than 3. So x is greater than, x is greater than 7 point something, correct. So can you have 7 in the set? You don't have 7 here, correct. You don't have 7 here, right. So x is greater than 7.3. That means you have 7 in the set. I'm sorry, you don't have 7, you have 8 in the set, okay, and then you have even 9 in the set. Do you have 10? You can have 10, okay, you can have 10. Why you can have 10? Because 10 minus 10 will be 0, 0 factorial is defined, right. So you can have 10, alright. So here, can you have 11? Can you have 11? You cannot have 11 here. Why you cannot have 11? 10 11 is meaningless. Out of 10 things, you cannot select 11 things at a time. Correct? There are only 10. How can you select 11? You cannot. 11 C 10 is meaningful. Okay. So 10 C 11 is meaningless. So x cannot be 11. You cannot put 11 there. Alright. So can you put 10? Yes, you can put 10. 10 minus 1 is 9. Allowed. So 11 is even allowed here, but because of this 11 is not allowed in this total inequation. Anyway, alright, so therefore you have got only 8, 9, 10. Now what about 8.1? Can you put 8.1 here? See, we are dealing with the objects here, right? So out of 10 things, can you select 8.1 things? Either 8 things or 9 things. Do you cut each thing? You don't cut each thing into 10 pieces and say 8.1, this is 8.1 and this is 8.2, this is 8.3. No, this is the 8th object, that is the 9th object, that is the 10th object. Anyway, so these are the totally 8 objects, these are 9 objects, these are the 10 objects. You don't have 8.1 object, 8.2 object, correct? You cannot have decimals there. Therefore, basically you cannot go for this. You cannot go for this, right? So this includes, doesn't include 7, but it includes 7.1, 7.2, 7.3, 8.1, 8.2, 8.01, 8.02. All the real numbers are included till infinity. But the thing is, you cannot go above 10 because of this. You cannot go above 10. Okay. So for two reasons this is not possible. One thing is, this is real numbers, decimals are not allowed here. Okay, and the second thing is you have till infinity, you need only till 10. Okay, and 1 to 3 obviously not possible because it should be greater than 7.3 or something. Okay, and 1 to 10, so less than 7.3 is also not allowed. So option D is the right choice for this question. So whenever you deal with the permutations and combinations, we are dealing with the natural numbers here. Okay, n factorial, that notation stands for only natural numbers. Remember the definition of factorial notation. What is the definition of n factorial? It is the product of first n natural numbers. Okay, so you don't have negatives, you don't have real numbers, decimals there. Fine. Okay, so that's about question number 1. Let's move to the second question. Okay, now dear students, let's move to the second problem here. You have got 2n plus 3c 2n minus 2n plus 2c 2n minus 1, that's equal to 15 into 2n plus 1. So, you have to use NCR formula in two places. So, let's begin with that. So, 2n plus 3 c 2n, so that is like 2n plus 3 factorial divided by 2n factorial and 2n plus 3 minus 2n factorial minus 2n plus 2 factorial divided by 2n minus 1 factorial and then 2n plus 2 minus 2n minus 1. So, minus and minus will be plus over here. So, that is equal to 30n plus 15, right. So, just multiply that 15 inside. Well, now let us simplify this factorial notations. What about this 2n plus 3 factorial? You can write it as 2n plus 3 into 2n plus 3 minus 1, correct. So, which is 2n plus 2 factorial. So, 2n plus 3 into 2n plus 2 factorial, you can still reduce it, but I am trying to take this common. Okay, I will do that later. Next, see, this is 2n factorial, let it be like that. For the time being, we will see what we can do later. We can reduce this because you have 2n minus 1 factorial here. So, I will take I will reduce it using n factorial formula. So, what is 2n factorial? 2n into 2n minus 1 factorial, and here cancel out 2n, you are left with only 3 factorial, which is 6, and minus 2n plus 2 factorial over here, and this is 2n minus 1 factorial. Once again 2n can be cancelled out, 2 plus 1 again, you have 3 factorial, which is equal to 30 n plus 15. Okay. Now, I am taking this common. Let me see what I can do with this later. Okay. So, divided by 6 3 factorial, and then this is 2n minus 1 factorial. I am taking this common out of these two things. So, what remains here is 2n plus 3 divided by 2n, right, and then over here basically nothing remains. So, 1 remains actually. So, all the 3 things are out. So, into 1. Okay. Then that is equal to 30n plus 15. Okay. So, we could take 15 out anyway. Now, let us simplify this so that we can get rid of that 2n, right. So, here you have got 2n plus 2, right. So, that can be written as 2n plus 2 into 2n plus 1 into 2n into 2n minus 1 factorial. So, 2n minus 1 factorial can be cancelled. We will do that. So, this is 2n plus 2 into 2n plus 2 minus 1. So, which is 2n plus 1 and 2n, right, and 2n minus 1 factorial divided by 6 into 2n minus 1 factorial, which can be cancelled out. I am taking LCM over here. So, this is 2n plus 3 and minus 2n divided by 2n, which is equal to 30 into 2n plus 1. Okay. So, cancel this 2n and let us work out with the remaining things. Alright, so you have got 2n, so you can strike that out. So I have got n and 2n plus 2, and then I have got 2n plus 1 divided by 3, not to forget that, and here I have got 3 by 2n, right? Okay, and that's equal to 30 into 2n plus 1. So, 2n plus 1 I will cancel on both sides, correct, and then what else I can cancel out is this 3 and this n, okay, and this 2 I will multiply on the other side. So, finally what do I have is 2n plus 2 is equal to 60. Okay, so I have multiplied this 2 here, that has been cancelled. Okay, so that is like 2n is equal to 60 minus 2, which is 58, which is equal to 58 by 2, which is, yes, so divided by 2, right? So that is 27, no, it's like 29. Well, so what else did we miss? This is 15, I am sorry. Right, so that's 15, my mistake, I am sorry, my mistake, I wrote 30 there, make it 15. So that's like 30 over here, and this is like 28, which is 14. Well, so 14 is the answer, option B. So option B is the answer for second question. All right, so this was a little lengthier question, but if you are good with the reduction of n factorial notation, you will solve this quickly. All right, so this is basically working out with the n factorial notation. Okay, so you have to identify similar things and simplify them. All right, so work as many problems as possible, which includes this n factorial reduction, n into n minus 1 factorial. Okay, so that will speed up your solving time. All right, so let's move on to the third question. All right, so let's go to the third problem here. You have got n minus 1 C3 and then n minus 1 C4, which is greater than n C3. Okay, so remember one formula, that is NCR plus n minus 1, NCR minus 1 is equal to N plus 1 CR. I hope you remember this. Okay, so NCR plus NCR minus 1 is equal to N plus 1 CR. Now, in place of N, we have got N minus 1 over here. Okay, and in place of R, I have got 4, and R minus 1 is 3. Okay, so write this in the proper order, or you can directly go for the answer. So in the answer, what should I write? N plus 1 if I have got N here, but if I have N minus 1, then this would be N minus 1 plus 1, which is N, and I should write R over here. So what is R? 4. Okay, this is R minus 1, right? So NC4 is greater than NC3 is what I get. So you have to remember that you have to use this formula so that we can reduce this sum of two combinations into just one single combination, right? So little is better, correct? Having too many things will complicate. You can take things common, you can use the formula NCR, take things common and work out. You can do that, all right. But if you go with this formula, then easily you can do. So you may ask why we did not use. One thing is this is negative. Secondly, this is not same. See, you should have same thing, N and N, right? So you have got 2n plus 3 and 2n plus 2. So we couldn't use there. Okay. So we can use it here, therefore we have used. Let's continue. Okay, so now NC4, let's use the formula, that is n factorial divided by 4 and n minus 4 factorial, which is greater than n factorial divided by 3 factorial and then n minus 3 factorial. Alright, so I can straight away cancel that, and 4 factorial I can write it as 4 into 3 factorial, right? And n minus 4, so n minus 4, let it be like that, and that is greater than 1 by 3 factorial, and n minus 3 factorial can be written as n minus 3 into n minus 3 minus 1, which is n minus 4. Okay, well, so now let me cancel these. Well, so what remains? You can multiply this n minus 3 over here, greater than this 4 can be multiplied here. So that means n is greater than 4 plus 3, which is 7. So n is greater than 7. Option A is the right answer for the third question. That was so simple, right? That was simple because we used this formula. Well, let's move on with the fourth question. Okay, look at the fourth question now. This is the simplest one. Within 1 minute or even within a half a minute you can get the answer of this. Okay, so if you know this pattern, you can just assume the answer. The answer is 1. Okay, let's see how. So first you have got NC9 which is equal to NC8. Okay, whenever you have a situation like this, you have two options. This implies either 9 is equal to 8, but here it is not, correct? So or n is equal to 9 plus 8, therefore n is equal to 17. Okay, so if you get n, finding this is so easy now. So what is NC17? So NC17 is like 17C17, which is NCN. So NC0, NCN both are equal to 1. Therefore option A is the answer for the fourth question. So that's a very standard question, very basic question. Let's move on with the next set of questions.
Don't forget to like our video and subscribe our YouTube channel for all the updates.